For section 4.1.40-T, Lyme disease is an inflammatory disease that results in a skin rash and flu-like symptoms. It is transmitted through the bite of an infected deer tick. The following data represent the number of reported cases of Lyme disease and the number of drowning deaths for a rural county. We're going to complete part A through C below. So we're going to draw a scatter diagram of the data. So here are the cases of Lyme disease and the drowning deaths. And then this represents the month. So the first thing we're going to do is that we're going to go ahead and click on the icon and then open up this data into StatCrunch. So we're going to open up this data into StatCrunch. And so next, we want to be able to create our scatter plot. So in order to create our scatter diagram, what we want to do is we're going to select Graph and then select Scatter Plot. And then we have to determine what is our explanatory variable and what is our response variable. Well, in this particular case, the first scenario here represents the cases of Lyme disease is the explanatory variable. So the cases of Lyme disease is the explanatory variable, which is X. The response variable is Y, are the drowning deaths. Okay? And then what we want to do is we then want to then label our X and Y axis. So coming down here, the X axis represents Lyme disease. The Y axis represents drownings. And so now what we want to do is we're going to go ahead and compute. And so if you notice here that our scatter plot matches the scatter plot that we have here. Okay, now what we want to do is we want to be able to determine the linear correlation coefficient between Lyme disease and drowning deaths. So in order to do that, we're going to go ahead and select Stat, Summary Stats, and go down to Correlation. And then we're going to select the cases of Lyme disease, hold the control button down for drowning deaths, and then we're going to select Compute. And so we end up getting a correlation number of 0.963. So therefore, using technology, we end up getting R, which is equal to 0.963. And so now what we're going to do is we want to be able to determine, does there a linear relation exist between the number of reported cases of Lyme disease and the number of drowning deaths? So in order to do that, we're going to have to compare the correlation coefficient to the critical value. The correlation coefficient is the absolute value of the number that we found, which is 0.963. In order to find the critical value, we need to determine the number that's in the sample, which is n. So if we come back up here, if we count the ordered pairs, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've determined that the sample size, n, is equal to 12. And so using the table to find the critical value, we'll come over here and find out where n is equal to 12, and then we can see that the critical value for that is 0.576. So the critical value then is 0.576. And now what we want to do is we want to compare that. So we can see that the absolute value of the linear correlation coefficient is going to be greater than the critical value. And since the correlation coefficient is positive and the absolute value of the linear correlation coefficient is greater than the critical value, then there is a positive linear relation between Lyme disease and drowning deaths.